Okay, question two, the other stereochemical question. And again, a little bit of context with it. Um, this is a particularly useful anti-tumor drug. Oddly enough, it's now used used in post-retinal surgery. Um, Oddly enough, it's now used as a post-treatment after eye surgery to prevent scarring on the cornea. So, in this case, we have basically four stereocenters to deal with. They are respectively this, this, and this. And in 3 out of 4, we're lucky because our number 4 priority group is already pointed away from us. There's a hydrogen here, there's another one here, there's another one here. There's not a hydrogen on that last stereocenter. It has 2 bonds to carbon up and down, the nitrogen to the left, the oxygen to the right. There is no low priority fourth group that's not being shown here, as there are with the other 3 stereocenters. So let's take a look. All right, so I'm going to start with the top one and work our way down to the aziridine ring at the end. So first case, we have this carbon here. Off to the carbon is here. This is the one I'm talking about. Off to there, we have this as an upward carbon. We have a number 4 priority group pointed away from us that we don't have to worry about. And we have this. Now, we have no heteroatoms attached here, so we're going to have to go another step further out. So 1 atom further from this, in the left carbon, is another carbon, another carbon, and another carbon. So these 2 represent this double bond. If we go upward, our next atom out from that carbon is an oxygen. That's good, that's high priority. And 2 hydrogens. If we go down, we're looking at now the next atom out there being a nitrogen or an oxygen. Or another carbon. So, we have oxygen versus oxygen, that's a tie game. But if we can compare the other 2, well, now we're looking at nitrogen versus hydrogen. This is going to take priority 1. This is going to be priority 2 because the oxygen that's left still is more important than the carbons over there priority-wise. And this will be priority 3. So that is counterclockwise. That is S. Okay. So let's look at the next one. Well, now I have the oxygen group pointed away from me. So that's exactly opposite to what I want because looking 1 atom out from our chiral carbon, we're talking about this one. 1 atom out from that, I'm looking at oxygen, that's the first priority group. So I can assign this and then just invert it, or I could rotate the whole thing like we did in the previous example. The nitrogen is going to be priority 2. And then what's priority 3 and what's priority 4 here? So up here I have a carbon, a hydrogen, and another carbon. That's my carbon labeled S there. Down here to the bottom left, I have a nitrogen. Another carbon, hydrogen. So that's going to take over as priority 3. So if this were drawn the right way, that would be S. But again, my number 1 priority group is pointed away from me, so I have to flip what I'm actually seeing here. So this is not S, it's R. Because I have to look at it from the other side of the way I have it actually drawn. I have to put my head inside the screen again. Or I have to rotate the whole structure 180 degrees to look at it. Either way, I'm going to end up with the opposite of what I have assigned here. So this one is actually R in the structure. So we've got S here, we have an R here. Now, moving on to this one. So for that one, I have the nitrogen bond, I have the carbon that forms the other bond to nitrogen. I have another nitrogen. Wait, sorry. I'm one carbon off. So I have a carbon from there, which goes to the oxygen and the nitrogen, the other ring nitrogen. And then I have my number 4 group pointed away from me again. So priority 1 here is that. Now my other carbon here has a bond to nitrogen. It's the same nitrogen, but I still have to count it for prioritizing. It has a hydrogen, and then that's another carbon. So, but the carbon above, this one, has an oxygen, which is going to take priority over this carbon's nitrogen. So that's going to be priority 2. This is going to be priority 3. This is S. So we have so far S, R, S. Now we've got the last one to deal with. So we now have that carbon has a number 4 hydrogen away from us. It has the aziridine nitrogen up. And it has this carbon, this one. So this is clearly priority 1, clearly priority 4. The next one's a little tricky because this has a nitrogen bond, a bond to nitrogen. It has another bond to carbon, and it has a hydrogen. This one has hydrogen, another hydrogen, and a nitrogen. It's this nitrogen. So the nitrogens are equal, but then I end up comparing one further atom out, and I have the H versus that C. This is priority 2. This is priority 3. This also is S. So, final answer is this. I have an S, I have R, and both of the aziridine carbons are S.